guys. Let's start with today's lit coding. Yesterday and the day before yesterday, I have a lot of work to do, and today I think I'm free, maybe for 30 minutes, and let's go through a quick question. Last time we finished the second question about binary search. Today, how about backtracking? What's this? Backtracking, I believe that's DFS or BFS. Let's have a look. Remember, I think it's maybe backtracking. So DFS. Mm-hmm. Oh, I forgot to share my screen. Yeah, sure. So I think we can see that. Mm, the question is giving a string containing digits from 2 to 9, inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Mm. So the question wants us to the input is digits. There is a string containing digits, and the output is all possible letter combinations. That's an array. And secondly, the method for this question is using DFS to do the backtracking. Um, for example, we can choose one letter from the first digit and another one for the second digit and the third one for the third digit uh, until all the digits have their own letters. After that, we backtracking and to change the letters last time the digit don't change, which means to change the letters in the backtracking field path. So the time complexity of this algorithm is that that is about 3 n. N is the number of the digits, 3 or 4. So I can say that the time complexity is big O for order of n, and n can see from 1 to 4, so that's not too much. And this algorithm um, is good in time complexity. And for the space complexity, firstly, we have to build an array to save all the numbers to save a lot of map and uh, let me think about it. We should use a map to save all the informations about the digit and letters. And in this map, each item k is a digit, and the value is an array about the letters. So let's build this information first. Const map and let's do some settings about this map. Map.set. The key is a string digits string, so it's not number. This we should focus. Um, we should know. So string 2 is the key, and the value is an array including A, B, and C. Let's do this again for digit 3, and the letter is D, E, F, and again letter 4, digit 4, the letter is J, H, I, letter 5, digit 5, the letter is J, K, L, digit 6, for digit 6, the letters are M, N, O, for digit 7, the letters are, there are 4 letters, P, U, R, and we add an S. So the digit A, the letters are T, U, V, and the 9. The letters are W, X, Y, Z. These are all about the initialization about the map. Uh, After we initialize this map, we can know that the time complexity of the search is O1 is in constant level. After that, we can use a recursive function to do this. So let's cast a new function, which is uh, we can call combination com which whose parameter is uh, firstly the digits and digits are strict. So and the return is string array. And firstly, for the if digits dot length is 1, you can just return all the possible for this and for this condition. So let's just return the map dot get the digits 0, the first digit. Okay, so when I get the digits in this function, I can get the first one digits 0 as a const called digit, and using this digit we can get a digit letter array about this digit. So we should get letters about this digit. The map dot get use this key, and after getting these letters you can use a for let I is 0, I dot length I plus plus, and in this loop each time we can get a letter from these letters, and these letters is about one digit, which means every time I entry to this recursive function, the digit we operating, we only operating one digit. We can use of as a const letter of letters. So this would be good. And we can add all letters into our result letters. Add this letter into the start of all the items in our result array. So we have to get an answer. Let's initialize it as an empty array, and each time I will get the com digits. Let's say slice. We have to cut this, right? From 1 to the n. Every time we get an array of this, including everyone inside of including all possible letter combinations about these digits dot slice 1. So after that, we have to add these letters in the top of all these results. So firstly, let's save these results. These are right letters. And for each item of these red right letters, this should be right combinations. We can add the letter and the right combination together and push this into our answer. So answer dot push. So after that, Oh, yes, we don't need to calculate this inside. You can calculate this outside of this for loop, right? Yes, I think so. And from here, we have to return the answer and just return these all digits. So change another name of this closure function. Okay. Oh, mm, every test case is accepted. Yes, I think that's all. Okay, mock interview finished. And let's ask AI if there is another problem of our code. Oh, so I didn't notice about that, but hopefully the test cases, the constraints about digits.length is from 1 to 4, not 0 to 4. If it goes from 0 to 4, I might be thought because of this boundary condition. And it mentions that we can also use array to not instead of map. we can use the backtracking algorithm. Oh, my algorithm is not backtracking. Backtracking algorithm is not DFS algorithm. A DFS, including the go forward and go backward. Oh, uh, AI means we need pop in backtracking algorithm. DFS is finding something, but backtracking is found finding everything. Mm. was int to index. Mm, and term is oct. Easy to understand. Cool. Okay, I think that's all for today's video. Thank you for watching